In lesson 2, the first example, we're going to simplify expressions that have negative exponents. So for a, before we can simplify this, we have to make the exponent positive. So I need to take the 3 and bring it to the top of the fraction. And that will make my exponent positive. So 3 squared is 9. For b, I'm going to have to take this 3 to the negative third power to the bottom of the fraction line so that we have 1 over 3 to the third power, which is 1 over 27. In C, we have a negative 3 to the power of negative 2. Notice that this negative 3 is not in parentheses. So I'm going to have 1 over negative 3 squared. So it's the same process we used over here of just bringing that down to the bottom of our fraction. And then we'll square our 3. We have 1 over negative 9, and that's our answer. Now this time in D, we have parentheses around our negative 3. So we still take this down to the bottom, just like we did before. 1 over negative 3 in parentheses squared. So this time it's 1 over a positive 9. Very important that you notice where the parentheses are, or if it has any. Alright, in E, we have a negative sign, then parentheses, and a negative 3, close the parentheses, to the power of negative 3. We need to, again, take this down to the bottom. So we'll have 1 over negative 3 cubed. Okay, now when we cube this, we're cubing our negative 3. So we're going to have 1 over, and this negative I'm just bringing down from that negative right there. And this is going to be a negative 27 when I cube that. So now we have the opposite of a negative 27, so it's 1 over a positive 27. The second example in lesson 2 is multiplying variables together, and we need to add the exponents of the like bases. So I'm going to add all the exponents of my x's together. So I'll have x, and then 2 plus negative 5 plus positive 5 plus 0. So the new power of x, these 5s would cancel, is just 2. Then we'll combine the powers of our y's. So I'll have y, let me write this out here, 1 plus a negative 4. That is supposed to be 4. So it's y to the negative 3. And then we have simplified our expression. The third example in lesson 2 has a simplifying a rational expression, and what we'll need to do is just start with simplifying the top all by itself, then simplify the bottom all by itself, And then you can move things around and add or subtract exponents as needed to get your x's and y's together on just one side of the fraction. So first we're going to concentrate on just simplifying the top. So I'm going to get all my y's together by adding their exponents. So I'll have 1 plus negative 3, which is negative 2, plus 5, which is a positive 3, so that'll be y to the third power. Then I'll combine the exponents of my x's. So that's 4 plus a negative 10, so it's going to be x to the negative 6th power. Alright, now we're just going to do that same thing on the bottom. So, combining my y's, I'll have negative 6 plus 10, so that's going to be y to the 4th. And then for my x's, I have x to the negative 3rd power, x to the 2nd power, so negative 3 plus 2 is going to be a negative 1. Alright, now at this point we can start moving things around. And normally you want to have your exponents to be all positive, unless it's stated that they want the answer in the numerator. Okay? So first of all, if we're just trying to keep all the exponents positive, I would move this down here and this down here. Now because both of these are being moved to the bottom, it will leave a 1 on top. Okay? And now, since I'm dividing here, I'm going to be subtracting the exponent. So this will be 4 minus 3. So that'll be y to the 1st power. And then on this one, it's negative 1 minus a negative 6. So really, it's negative 1 plus 6, which is going to be a positive 5. Right. Now this is the simplification whenever we're trying to just keep our exponents positive. Now, if it asked us to write our answer in the numerator, we'd simply move these to the top. So we'd have y to the negative 1 and x to the negative 5. So both of these answers are correct, they're just in different formats. The fourth example in lesson 2 adds the element of a power to another power, and when it's a power to another power, we multiply those together. Now we still start the same way with simplifying the top by itself and then simplifying the bottom by itself. So first I'll have x times, now I'm going to go ahead and just do the powers first, distributing that. So here it'll be x to the negative 6th power, leave y as it is. Then this is going to be x to the negative 3 power, and y to the 6th power. And on the bottom we'll have y to the 6th, y to the negative 3 is just staying the same, and x to the 6th power. Alright, now that I've multiplied those powers together, I can go ahead and start simplifying where I started earlier. So I'm going to add my x exponents together. Remember that when it does not have an exponent written, that means that it has an exponent of 1. So this is going to be 1 plus a negative 6, which is negative 5, plus a negative 3, which is negative 8. Then next, I'm going to combine my y's. So I'll have y, and this has an exponent of 1, so 1 plus 6 is 7, so that's y to the power of 7. Then on bottom, I'll have y, let's see, it's 6 plus a negative 3, so it's going to be y to the power of 3, and then x to the power of 6. Now at this point, we want to get our x's together and our y's together. And what I'm going to do is just keep my exponents positive, but again, depending on what your directions say, whether you want to have your answers or all your variables in the numerator or the denominator, or keeping exponents positive, do whatever the directions tell you to do. So I'm going to take this x to the bottom, and I'll take this y to the top. So on top, I'll have y to the 4th, and on bottom, I'll have x to the power of 14. And then this is going to be our simplified version of the answer. And again, depending on what your directions say, is where you're going to put your variables. In the fifth example, in lesson 2, we are given the area of a circle, but asked to find the circumference of the circle. So what we'll need to do is start by finding the area, or using the area with the formula for the area of a circle. So we'll have pi r squared, because that's the area of a circle, equals the 12.2 meters squared that we're given. So what we'll need to do first is divide both sides by pi. So r squared equals 12.2 divided by pi, still meters squared. And then take the square root of both sides to eliminate the square, and that will give us approximately 1.97 when we take the square root of that. And that'll just be in meters. Now the area, or not the area, the circumference of a circle is 2 pi r. So what we'll do is fill in 1.97 for r here, and multiply these together, and that'll give us approximately 12.38 meters for our circumference that we were looking for. In the sixth example, in lesson 2, we're given the circumference of the circle, and then we're trying to find the area. So again, we're going to find out what our radius is. So we'll divide by 2 pi. I just used the area, or the formula for circumference. So our radius is 4, and then we'll just put that in for the area of a circle. So it'll be pi r squared, so that's pi 4 squared in this case. So we'll have 16 pi for the area of our circle. And it was in centimeters, so that'll be centimeters squared since it's area. So remember, I just started out with the formula for circumference, solved for the radius, and then put that answer in place of the radius in the formula for the area of the circle to find our area.